Hi everyone, hope everybody is okay. In this video, I want to go over graphing some trigonometric functions by shifting them horizontally, vertically, and show you all the details. So I put 10 functions here. I did 7 of them for you, and then we'll go over 7 of them, and the rest I think you can take care of that yourself. So let's start. I wrote them here, we have it here. The first function is right here, 3 cosine 2x plus 2, and I ask you to do 2 periods. So I put all the steps for you. Step number 1, we know that the period of cosine x is between 0 and 2 pi. So what you need to do is take the angle and put that between 0 and 2 pi. Do not multiply 2 by 3. It's not going to work. You can, that's the angle and stays that way. So you can isolate x by dividing all the sides by 2. So you're left with 0, x, and pi. Now, second step is to get some information. We start from 0. If we start from 0, that means there's no phase shift. This graph is going to start from 0 and end at pi. That's just one period. The amplitude of the graph is absolute value of this number, which is 3. The period, to find the period, you always take that number minus that number. Pi minus 0 is pi. Third step is to get some points on the graph, and you need to show all these points. So to get those points, we know the period has 4 major parts. So you take the new period, which is pi, and you divide that by 4, and you start with the starting point, which is 0. That's the first point on the graph for that period. Then you do 0 plus pi over 4, which is that number. It's pi over 4. That's the second point. Then pi over 4 plus pi over 4. Always you add that number. So that's 2 pi over 4, which is pi over 2. Then pi over 2 plus pi over 4. Again, same number. And if you get the LCD is 4, so you get 2 pi. 2 goes into 4 2 times, so 2 times pi is 2 pi plus 4, and that's 3 pi over 4. And the fifth point, or the last point of the first period, will be 3 pi over 4 plus pi over 4, and that's 4 pi over 4, which is pi. So one period is done, but if you want to continue, you can just keep adding pi over 4. So pi plus pi over 4 is 5 pi over 4. 5 pi over 4 plus pi over 4 again is 6 pi over 4, which is 3 pi over 2. 3 pi over 2 plus pi over 4. Again, I showed the LCD one more time. 2 goes into 4. 2 times 3 is 6. So 6 plus pi is 7 pi over 4. And 7 pi over 4 plus pi over 4 is 8 pi over 4, which is 2 pi. Basically, if you come here and you want to go one more period, that means one more pi, you're going to get 2 pi. So, and we did get 2 pi. So that's the last point on the graph. Now we're going to graph this function. So we have our information. First, find the new axis. So the new axis is plus 2. So you shift up 2, and I did draw the new axis here. Then we know the amplitude is 3. So from this axis, go up 3, 1, 2, 3. So it's 5. Mark that point and go down 3 to 3, which is -1. So we know the graph is going to oscillate between -1 and and 5. Place the points. The first point is pi 0. The second point is pi over 4. Then pi over 2, 3, pi over 4, pi, and so on. So I placed all those points. Pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and so on. And the last point we know it was 2 pi. So we are graphing cosine. Cosine we know, starting point, the regular cosine is 1. So the regular cosine is 1 and it goes down like that. So basically that's what we're going to graph. So it's 1 second point on the graph. Cosine is, the graph is on the axis, crosses the axis. Third point, it goes down. Fourth point is up on the axis again. And fifth point is it goes up. Then we have the second period, so we continue. We come back to the axis, then go down and come back to the axis and go up again. So basically, and I put the periods for you. That's the first period and that's the second period. And the graph, they look exactly the same. So basically, once you know one period, then you can keep going. If it's more period, this graph was going to continue. Let's do number 2. Number 2 is negative sine minus pi x minus 3. When you have a negative sign next to x, it's much easier to use this identity. We know that sine negative theta is negative sine theta. So write this as negative 3 sine pi x because it's much easier to deal with that. Of course, minus 3. One more time, don't multiply this by 3. Just take the angle and put that between 0 and 2 pi because the period of sine is also 2 pi. Isolate x. How do we isolate x? We divide every single term by pi, so you get 0x2. Pi is gone. We just have a number, but there's no problem with that. We can continue the same way we were graphing. We start from 0, so no phase shift. The amplitude is absolute value of negative 3, which is that number now, not this one, and it's 3. So the period is that number minus that number. 2 minus 0 is 2. And so we have all this information. Step number 3, we're going to do the points. To do the points for all the functions, take the period and divide it by 4. Because all those trigonometric functions have 4 major points in their period. So 2 divided by 4 is 1/2. Starting point again, it's 0. Then you keep adding 1/2. 0 plus 1/2 is 1 over 2. 1 over 2 plus 1 over 2 plus 1 over 2 is 1. 1 over 2 plus 1 plus 1 over 2, that number is going to give you 3 over 2. And 3 over 2 plus 1 over 2 is 2. Check the starting point and the ending point. 0, 2. It matches, so we're doing it right. Step number 4 is the graph. Put the points first. So we have 0, 1 over 2, 1, 3 over 2, and 2. Place them here on the x-axis or below the x-axis, not here. So then draw the new axis. The new axis, it's negative 3. It's always that number. That's basically the vertical shift. So negative 3, I have it here. Then check the amplitude. The amplitude is 3. That means the graph is going to go up and down 3 from the new axis. Up 3 is 0. I put it here, and down 3 is -6. Basically, now we know the graph is going to oscillate between 0 and -6. So now we're graphing sine. Sine starts from 0, goes up, down, and then hits the axis again. So you're going to have the same type of graph. First point on the graph is 0. Sine goes up, but you have to be very careful because now we change the sign. It's negative. So it's going to go down 3 from the axis, and we have these points, so it's easy now. Then second point is on the axis. Third point, it goes up, and fourth point, it comes back to the axis. Basically, you connect these points, and that's the graph, and only one period is enough. Next one, 2 tangent pi over 7 times x plus 1, and I said 2 period here too, so let's remember. We know tangent, when we did the original graph, it goes from -pi over 2 to pi over 2. So that's just the best period. You can divide for, we can graph for tangent x. So anytime you have tangent and the angle is different, you take that angle and put that between -pi over 2 and pi over 2. Isolate x. How do we isolate x? Multiply every single term by the reciprocal of pi over 7, which is 7 over pi. If you do that, the first one, pi's cancel, so you have -7 over 2, and here it's gone, you're left with x. And here, pi's cancel, you get +7 over 2. So the first period is going to go, this graph is going to go from -7 over 2 to +7 over 2. Phase shift, which is the horizontal shift, is always that number, -7 over 2, or sometimes they take the absolute value of that number, 7 over 2, but you know it's going to be to the left because it's negative. The coefficient tangent does not have amplitude because it doesn't go up and down, but it has the coefficient that we have to be careful. So that coefficient is 2. So basically it's going to go from the axis up to and down to. So we're going to, I'll show the graph. So, and I put the note for you. Tangent does not have an amplitude. The period, always that number minus that number. So it's 7 over 2 minus -7 over 2. That's 7 over 2 plus 7 over 2, which is 14 over 2. And that's 7. Points on the graph one more time. Always take the period and divide that by 4. So you get 7 over 4. Starting point of the graph is -7 over 2. So first point is -7 over 2. Second point is -7 over 2, or that, plus 7 over 4, which is the period divided by 4. And you did -7 over 4. -7 over 4 plus 7 over 4 is 0. And you keep adding. 0 plus 7 over 4 is 7 over 4. And finally, 7 over 4 plus 7 over 4 is 14 over 4, which is 7 over 2. These are the points for the first period. So let's check if you're right. Yes, it's going to start from -7 over 4, 7 over 2 to 7 over 2. So that worked. Second period, you keep adding the points. 7 over 4. 7 over 2 plus 7 over 4 is 21 over 4. And 21 over 4 plus 7 over 4 is 7. 7 plus 7 over 4 is 35 over 4. And finally, the last point, if you add this 2, you get 21 over 2. Usually the 9th point is going to be the last point on the graph. But if you want to check that, you can just take this 7 over 2 and add the period plus 7, and that's going to give you 21 over 2. So to see if you're right. So what? One more time, you take 7 over 2 plus 7, which is the period, and you get 21 over 2, which shows the last point. Let's graph it. So we're going to starting point is, we can put our axes here. So this is the x-axis and that's the y-axis. Starting point is negative 7 over 2. Be careful. 7 over 2 is right here. And I kind of put 7 over 2, then we go 7 over 4 each time. That means half of that. So the second point is negative 7 over 4. Then it's 0, 7 over 4, 7 over 2, and so on. You place all those points. The new axis of the graph is plus 1. So, and I can put 1 here, plus 1, and you can draw the new axis just like I did. Now we're doing tangent. So, and the coefficient, if we come back here, the coefficient is 2. So you know you're gonna go up and down 2. So let's look at this from the new axis. If I go up 2, it's 3. If I go down 2, it's negative 2. So maybe we should fix this. Let me fix that. And we can put that point here. So if I fix this, then I'll so basically it's right here. So again, it's going to go from negative 2 to this code. This is a helpful information to graph tangent. Now the regular tangent, I'll do that fast here. We know it's from negative pi over 2 to pi over 2, and the graph looks like that. So we do the same way. Let's do it. First period, we know that starting and ending, we have vertical asymptotes. So we have our vertical asymptote here and vertical asymptote here. Second point, tangent is at negative 2 from the axis 1, 2. Just write the regular tangent. It's right here. So it's negative 1. But for this one, it's going to be down 2 from the axis. Third point, it's on the axis. Fourth point, it goes up, just like tangent, and then approaches the asymptote. Same thing for the second period. Starting point, we know it's an asymptote. The last point was 21 over 2, which is also an asymptote. So start this brand new starting point. It's going to be at, tangent is at negative 1, but here our new graph is going to be 2 units down from the axis. Right in the middle is on the axis, and it's 2 units up from the axis, and it approaches the asymptote. So basically that's the graph. Number 4, 3 secant pi x plus 5. So if you're You want to graph secant. You know that secant pi x is 1 over cosine pi x. And I put, let's graph, I call this function g of x because it's not the same thing as that. 3 cosine pi x plus 5. It's much easier to graph cosine first, then get the graph of the secant from the graph of cosine. Cosine, we know the period is between 0 and 2 pi. So take the angle, put it between 0 and 2 pi, isolate x by dividing all three sides by pi, or what we're doing, we're solving this compound inequality. That's how we call that. Compound inequality, solving compound inequality, that means having x in the middle. So we get 0, x, and 2. Now we know this graph is going to go from 0 to 2, starts from 0, so no phase shift, basically, no horizontal shift. Amplitude is absolute value of that number, which is 3, so it's going to go up and down, just one way 3, sorry, up or down 3. The period is 2 minus 0, which is 2. And if you want to get the points, first step, again, for all of them, take the period and divide by 4, and you get 1/2. Starting point is 0. We got that from here. Second point is 0 plus 1/2 is 1/2. Third point is 1/2. Actually, 1/2 plus 1/2 is right here. It's 1, and so on. You do 1 plus 1/2 is 3 over 2. 3 over 2 plus 1/2 is 2. Let's prepare the graph. So that's x, that's y. The points, you place them, and by now I think you know how to do that. The first point is 0, then it's 1/2, then it's 1, 3 over 2, and 2. 0, 1/2, 1, 3 over 2, and 2. New axis is that number. So basically, I can put here y equals to 5. 1, 2, 3, 4, 5. And the amplitude is 3. So from the axis, you go up 3 and down 3. So we know sine is going to oscillate between these two numbers. So we are doing, not sine, cosine. So we are doing cosine. So make sure to remember the original graph of cosine looks like that. So first point, so cosine here is going to go up, start from this point. Second point is on the axis. Third point, it goes down, and it's on the axis, then it goes up again. So this is, the dotted one is cosine. Now what we know, secant has an asymptote when the cosine is 0, because cosine is, secant is 1 over cosine. So 1 over 0 is undefined. Undefined means a vertical asymptote for the graph. Here, this function is 0 whenever it crosses the new axis. So it crosses here and here on the cosine. So whenever the cosine graph crosses the axis, draw a vertical asymptote. Now we want to do cosine, cosecant. So we know at this starting point, they share that point. It's the same for both of them. Then cosecant has to go and approach the asymptote. Here they share that point. It's the same for both functions. But cosecant has to approach the asymptote, so it goes down. Do not go up. They don't intersect. And finally, last point, this is gonna, they share that point together. So secant is gonna go up. So the red graph here is secant, and the dotted one, as I told you, is cosine. Always, if you want to graph secant, graph cosine, and it's going to be much easier. Same as cosecant. First graph sine, then graph cosine. Number 5, there we go. We have a cosecant here. Negative 2 cosecant x minus 4 minus 2. And I wrote it here. Cosecant x minus 4 is the same thing as 1 over sine x minus 4. So let's graph this first. Negative 2 sine x minus 4 minus 2. We know that the angle is going to be between 0 and 2 pi because the period of sine is 2 pi also. Same way. So this is a compound inequality. Solve that by adding pi over 4 to all three sides. So if you do that, you get pi over 4 x and 9 pi over 4, starting and ending. So amplitude is absolute value of this number. So it's 2. Phase shift, the graph is going to start from pi over 4. So the phase shift is pi over 4. Period, 9 pi over 4 minus pi over 4. If you do that, you get 2 pi. Points on the graph, one more time. Take the period and divide that by 4. 2 pi divided by 4 is pi over 2. Starting point is pi over 4. Second point is going to be pi over 4 plus pi over 2. And I did the calculation. You get 3 pi over 4. Third point is 3 pi over 4 plus pi over 2. And if you do that, you get 5 pi over 4. Fourth point is 5 pi over 4 plus pi over 2, which is 7 pi over 4. And finally, the last point, if you add pi over 2, you get 9 pi over 4. And we double check. Starting is pi over 4. Ending is 9 pi over 4. Ending is 9 pi over 4. So it's correct. The graph starts from pi over 4. So pi over 4, then each time it goes pi over 4, that means double that number. So pi over 2. Second point is 3 pi over 4. Place your points. So we know what these points are. And we're graphing sine. So we know sine. I'm going to do it sine. The regular sine goes up and down. However, this one is negative. Negative, that means it has to go down and up. First point with pi over 4, sine is on the axis. So, the axis we have to fix. Let's see if we have, or minus 2. So let me fix this one. So let's go over this. We said the new axis is going to be negative 2. It's right here. So negative 2, so we can draw the new axis here. And then the amplitude is absolute value of negative 2, which is 2, so it's going to go up and down 2. So let's get those points up and down. So it's 0 and negative 4, so that's right. Sine, when sine starts, sine starts from the axis, and then second point it goes up, but as I said here it's negative, so it's going to go down right here at negative 4. Then it comes back to the axis and it goes, third point, it goes up, and it comes down to the axis. So basically, if we draw a sine, it's going to be like that. But we want cosecant and not sine. We know wherever sine crosses the axis, it's 0 for that function. So 1 over sine is going to be 1 over, she's undefined, so you're going to have your vertical asymptote. Each time sine crosses the axis, secant is going to have vertical asymptote. So when we start, they share this point basically, so secant has to approach the asymptote, and they share that point, so secant has to approach the asymptote. So let me go ahead and graph that for you. So again, the red one is the cosecant graph. Number 6, cotangent, -2 cotangent x minus pi over 2 minus 3. Do not forget the cotangent, the period for cotangent is pi. So you take the angle and put it between 0 and pi. For sine and cosine, you always put it between 0 and 2 pi. Tangent, -pi over 2 to pi over 2. And the best period for cotangent is from 0 to pi. Solve the compound inequality by adding pi over 2. If you do that, you get pi over 2. X is between pi over 2 and 3 pi over 2. Just like before, phase shift is pi over 2. The graph is going to start from pi over 2. Tangent is like cotangent. Cotangent is like tangent, no amplitude. So what you know the coefficient is -2. Period, you take that number minus that number, always. And if you do that, you get pi. To find the points, you take the period and divide it by 4. And you start. Starting point is pi over 2. With that point, add pi over 4. So you get 3 pi over 4. Next one is 4 pi over 4. And 3 pi over 4 plus pi over is 4 pi over 4, which is pi, and so on. 5 pi over 4 and 3 pi over 2. So let's prepare the graph. First of all, the new axis is -3. So I went down 3. The coefficient is -2. So we're going to go up and down 2. And let me fix that. So it's -3 if we go up and down 2. So it should be here. That's so basically it's from, if I go up 2, that's -1. If I go down 2, you can fix that too. So that's going to be -5. So, and we can fix the graph too. So let's start. And I can graph that for you here so you can see how this works. The graph of cotangent, regular cotangent, I put it here for you. It starts from 0 and ends at pi. So these are the 4 points: pi over 4, pi over 2, 3 pi over 4, and pi. We have asymptote starting and ending. So for our graph, we're going to have asymptote starting and ending. Cosine, cotangent goes at pi over 4 is 1. It's right here, but our graph was negative cotangent, negative 2 cotangent. So start is asymptote. The second point will be right here. The third point, so third point, basically the second point, 1, 2, or 1, 2, 3 is on the axis, so it's going to be here. And next one is going to be not there, but at negative 1. Because that's where the coefficient is, plus or minus 2 from the axis of the graph. So you can take this out. And if you want to draw this, we know it's going to go like that and come down. So let's graph this. Number 7, we have negative 2, negative 1 over 2x plus 4. If there's a negative sign next to x, it's better to factor it because it's going to be very easy. So you can say negative 2 cosecant, negative 1 over 2x minus pi over 4, since I factored the negative sign. Why did I do this? Because you can use that. So take that negative and that negative out, then you're left with 1 over 2 cosecant 1 over 2x minus pi over 4. So now it's much better to graph sine first, and it hasn't changed. Same way, you take the angle, put it between 0 and 2 pi because it's sine. And if you can graph sine, then come up with the graph for cosecant. So how do you isolate x, or how do you solve this compound inequality at pi over 4? First, I think by now we all know. So you get those numbers, and in the middle is 1 over 2x. Multiply every single term by 2, because that's 2. So that's what you get. The rest is exactly the same way. Starting point, ending point, phase shift is that, amplitude is 2, period is that number minus that number. So you get 4 pi. Then you get your points by dividing the period by 4. Starting is pi over 2. Then you add pi each time that number. So, and I'm sure you all know how to get those points by now. Prepare the graph, and let's see, there is no vertical shift here because no number plus or minus, there's no number here. So therefore, it's just from 0. Draw sine first, and from sine get secant. So this was number 7. Number 8, number 9, and number 10 is exactly the same way. So look at this recording and try those on your own. All right, everyone. Hope you have a good one, and I'll see you soon.